All right, so now let's take some notes. What do we know about equations that are always true? Equations that are always true are trig identities. Okay, they're actual mathematical properties that we can use because they are always true. So let's look at some examples of trig identity that we have actually learned already. Okay, first one, tangent is sine function divided by cosine function. That is always true. So we say that this is actually a trig identity. It's a trigonometric identity because this is always true. There's another one that we have done a couple times before, a Pythagorean identity. You can write it as cosine squared theta, the sine squared theta equals 1, or this is another way of writing it. And that comes from the triangle inside a unit circle, where hypotenuse is a 1. The horizontal length is represented by the cosine from the screamer, whereas the vertical distance was the sine function. Pythagorean theorem, cosine squared theta plus sine squared theta is equal to 1. We call that Pythagorean identity. Okay, and the new ones we learned today. The 12-2 part C, we saw the graph where the sine graph was actually exactly the same as cosine graph shifted over by pi over 2 radians. Cosine graph was exactly the same as the sine graph shifted over by pi over 2 radians. We saw that the graphs are exactly the same for both left and right side, so they're always true. And we call these co-function identity. There is another way to write this, and there's actually a lot more, but another version would be using degrees rather than radians. So pi over 2 is 90 degrees, so this can be written as sine of x equals cosine of 90 degrees minus x is equal to cosine of x equals sine of 90 degrees minus x. It's just another way of writing this co-function identity and using degrees as units. Now I want to take a moment to briefly explain this identity to you using the right triangle inside unit circle. So take a moment to just watch it, try to understand it. It actually just has to do with sine and cosine functions, the sine and cosine ratios. So if you have a right triangle with hypotenuse of 1 from the unit circle, let's say that I call this side A and side B, and here is my angle. I don't know the value of the angle, so I'm just going to call it a theta. Now, for this triangle, I know that sine ratio, sine of that angle, is opposite over hypotenuse, so it's going to be B over 1. And cosine is adjacent over hypotenuse, so it'll be A over 1. Okay, that's true. That's how you use trig ratio, sine and cosine. Now, because this is a 90-degree angle, this is a right triangle, if that's 90 degrees and that is some angle, we don't know it, but it is an angle, then we can say that this missing angle is going to be 90 degrees minus that unknown, right? Because these two have to add up to 90. So then, I don't know the exact value of any of these angles, but I at least know that this one is going to be found by subtracting this from 90. So then let's actually use that and find sine value of that angle. Sine of that angle, which we're going to call just 90 minus theta, is opposite over adjacent, right? So that's A over 1. And if we do it for cosine, cosine of that angle is adjacent over hypotenuse. So this time the side opposite to that angle is going to be B. So it ends up being B over 1. And if you look at it, you can notice that sine theta is actually same value as cosine of 90 degrees minus the theta. They're both equal to B over 1. They have the exact same ratio, which means they're going to be equal to each other. And cosine, which is A over 1, is equal to this one, sine of 90 degrees minus theta. And those are, again, the co-function identities. These will always be true. And we're going to come back and talk about this a lot more later on in this course before the end of the school year. So keep this in mind. All right, so then for the last part of today's Chapter 12 lesson, you are going to be working on that backside of your handout, which is 12-19. I'm going to have you pause the video or stop the video, work on that problem on your own first, and I'm going to talk about some parts of this problem in the video. So, all right, so now let's talk about 12-19. If you're solving cosine of x equals 1/2, the first question is, when is this true? What do the solutions represent? So first of all, solutions are the x, and x is representing the angles that have cosine value of positive 1/2. So if you think of unit circles, okay, angles that have positive cosine value of 1/2 are in quadrant 1, which is going to be in pi over 3, and you also have another angle in quadrant 4, 5 pi over 3, that has a cosine value of 1/2. So you can say that this is going to be sometimes true when x is equal to pi over 3 and 5 pi over 3. But these are your two solutions for one unit circle between 0 to 2 pi, okay? That's within one unit circle. However, think about this. You can go around the unit circle many, many, many times, right? You can go around the circle infinitely many times. So technically, there are going to be multiple solutions. From pi over 3, you can go around the full circle again and come back to it. Add 2 pi, going around 360 degrees one more time. Add another 360 degrees, add another 360 degrees, add another 360 degrees. You can keep going around the full circle 360 degrees, and you will still come back to that position that will always have a cosine value of 1/2. So now, if you're asked to give all solutions, which is going to be infinitely many, okay, you're going to have to write your answers as an equation. From pi over 3, from that angle, which has a cosine value of 1/2, you can go around an angle, go around the whole circle, 2 pi radians, which is 360 degrees. You can go again, you can go again, go again. It's a sequence. Keep adding 2 pi. So then you can write your answer as pi over 3 plus multiples of whole circle, 2 pi n. That's for the angle in quadrant 1. But we also have an angle in quadrant 4, 5 pi over 3. So from 5 pi over 3, from that position of the circle, you can go around the circle 360 again, 360, 360, every 2 pi radians or 360 degrees, you will come to this position that has a cosine value of 1/2. So you can also say 2 pi times n, and that's for the equation of angles in quadrant 4. And that's what we're looking at. Sometimes you may be asked to give only answers between 0 to 2 pi. Then this is your solution. But if we ask for all solutions, then because there are infinitely many, you have to write your answers as equations. That's the difference we're looking at now. So that's why if you worked on part B, I graphed cosine and graph the right side of the equations. And if you graph, and I mean my cosine graph go all the way up to 1 at 4 increments, so that's why my cosine graph may be a little higher than yours. But cosine graph intersects a y value of 1/2 infinitely many times. This is all the points of intersection we can see on this graph. But graphs are continuous, both direction, remember? So then there are actually going to be infinitely many more intersections, and that's why we have infinitely many answers. Okay, so then if you think about it in a unit circle, here's the issue. Thinking about it in a unit circle, we're limited. We're limited because How many solutions do we see on one unit circle? On one unit circle between 0 to 2 pi, we only see two answers. One answer in quadrant 1 and another answer in quadrant 4, right? Now, this is what you have to keep in mind. You have to keep in mind that, however, there are going to be infinitely many more because you can go around the circle infinitely many times. So even though for quadrant 1, we have an answer in quadrant 1, one angle of pi over 3. If you go around the whole circle again, which is adding a 2 pi, here is your next solution. And then you can go around 2 pi again. So if you add another 2 pi, that's another answer. And then you can go around the circle again from that position, go adding another 2 pi, and you can keep going. Therefore, since we can't list every single answers, we write our answer as an equation. Pi over 3 plus 2 pi times n. We write it as an equation. Same thing, we also have an angle in quadrant 4, so we're going to have to do the same thing. We start at this angle in a unit circle, but we can go around it infinitely many times, 2 pi radians, so 2 pi times n for all solutions. So things are getting a little repetitive here, but the whole point is that don't limit your answer to just one or two solutions. Just because a unit circle shows only two answers doesn't mean that's it. There are actually infinitely many more. Okay? Now, part D is now talking about solving this using a calculator. And here's another issue that comes up if you're solving it using calculator. Let's first talk about how we can use calculator. So to solve this, cosine of x equals 1/2. From integrated 2, you'll learn that you can inverse cosine both sides. So if you take inverse cosine of both sides, they cancel out, so you get x equals inverse cosine of 1/2. Now pop out your calculator. We're going to put this answer, we're going to put this in a calculator. First, we're going to do it in radian mode. So for my calculator, I'm going to press that button DRG, which allows me to select RAD, which is a radian. And I'm going to do inverse cosine of 1/2. And I get a decimal answer. That's approximately 1.047. Okay, but guess what? That's actually equivalent to 3.14 divided by 3. Or, in other words, pi divided by 3. So you can check it yourself. But we got that number using inverse cosine. If I do pi divided by 3, I get the exact same number. So even though the calculator doesn't exactly state as pi over 3, that decimal, it is equivalent to pi over 3 radians. So they're giving radian answer. Now let's try this with degree mode. We try it with degree mode. So I'm going to go back to DRG, change it to degrees. I'm going to do inverse cosine of 1/2. This time my answer is 60, which means this is now 60 degrees. And 60 degrees is equivalent to pi over 3 radians. So I still get the same answer, just now this is in degree mode. So that's how you use calculator. But here's the thing. Calculator only gives one answer. It only gives answer as pi over 3 radians. It only gives the answer in quadrant 1, but that's not all. Cosine is equal to positive 1/2, also in 5 pi over 3. And this is the issue. The calculator only gives one answer in quadrant 1. So you can't rely on it solely. The calculator is not going to give you all the answers that you need to find. You're going to have to rely on your knowledge of unit circles, and you do have to keep in mind that there are always going to be infinitely many solutions. Okay, that's why part E, you want to always write answers as equations if you're asked to give all solutions. Okay, so then for that last part in your handout, please make sure that you are answering 12-22, and then after that you can come back to look at my solutions with a little bit more explanations. But keep in mind that if you're asked to find solutions only for domain between 0 to 2 pi, then you're only asked to find answers within one unit circle. But sometimes you could be asked to find all solutions. So make sure you look out for that, but we will definitely practice this more next week.